All right, we're going to finish looking at some of the problems in section 2.2. This one is talking about strange behavior near x equals 0. And it says create a table of values of sine of 1 over x for the following values. So what I would do is, again, I would go and graph this, and I would change my table so that I could enter in whatever values I wanted. So I would go to y equals and do sine of 1 divided by x. Put that on here. And then I'm going to make sure that my table, so second table, is on ask. Doesn't matter what the table start is and stuff when I put it on ask. And then when I go to that table, I'm going to enter in these values up here. So I'm going to do 2 over pi, 2 over 3 pi, 2 over 5 pi. One thing I want you to notice here is notice that there's a pattern. In these fractions, all the numerators are 2, and the denominators are the odd numbers times pi. And so what's interesting here is that, and I don't know why I'm taking this side note, but it's kind of cool. The x values here would be 2 divided by, well, the way that we write odd numbers is we write them as 2n plus 1. And so 2n plus 1 times pi. So that would be my x sub n. And that would be where n starts with 0. Because when n starts with 0, 2 times 0 plus 1 is 1. And then when n equals 1, 2 times 1 plus 1 is 3. And so on. And so that 2n plus 1 starting with 0 will lead you to the odd numbers. So that's kind of interesting just to notice. But all I'm going to do is plug them into my calculator. So let's do that. So second graph, delete, delete. So 2 divided by pi, and then 2 divided by 3 pi. Oops, I don't know why I hit that. Oh, I typed it in wrong. That's tricky. It's 2 divided by, and then in parentheses, 3 pi. Because you want it to multiply. That's a little tricky. So then 2 divided by parentheses 5. Oops. Got carried away there. 5 pi. And then 2 divided by 7 pi. Oh, I did it again. Get carried away. It's kind of exciting. Look at what's happening. The values are alternating between negative and positive 1. And so that's kind of crazy. Which one did I just do? 1, 3, 5, 7. So this is 9. Parenthesis 9. I'm doing it right now. Huh? And then the last one, 2 divided by 11 pi. All right. So, again, all I did here was I typed in these values. So this was 2 divided by pi, and then 2 divided by 3 pi. Must have those parentheses. 2 divided by 5 pi. 2 divided by 7 pi. 2 divided by 9 pi. And then 2 divided by 11 pi. It's kind of sloppy. But anyways, they alternate between 1 and negative 1. And so it says, the next question is, why does the graphing utility have difficulty plotting the graph near 0? So, for example, if I went and I did graph here. Now, my graph is not scaled the same way their graph is. So on their window, it looks like they go from 0 to 2 pi over 5. or 2, sorry, 2 divided by 5 pi. And I'm going to go by increments of 0.01 here. And then it goes negative 1, 1. See what kind of craziness. There we go. That's a little more crazy. So that's a little bit more like what they have. But the problem is, so I'll just put this in here so people can see. So right here I did 2 divided by 5 pi. Is that it's infinitely bouncing back and forth between 1 and negative 1. And so that's a problem. So for part B, where it says, why does the graph have difficulty plotting the sine of 1 over x? It's because the values near, really the x values near 0 oscillate. I can't spell oscillate. Oscillate wildly. Wildly. Between negative 1 and 1. And then, so this would be my answer to part A. And this is going to be my answer to part B. And then for part C, what can you conclude about that limit? Well, it's never going to exist. It does not exist because it's not going to approach anything because it's bouncing back and forth between 1 and negative 1. So that's how I would look at this problem number 25. That's interesting. The next problem wants me to sketch the graph of a function with the given properties. I think on yours you guys have a little advantage because I think it gives you the graph. But I'm going to show you how I would build this graph. So, the first thing I'm going to do is I'm going to put dots where it's, you know, or points where there's actual points. And so I think the only place, nope, here's Y, here's X. I've got this point, and this point. So f of 1 equals 0. So that would be right here. F of 2 equals 4. So let me do this. They're a little bit bigger. 1, 2, 3, 4. So that would be a point right here. And then f of 3 equals 6. Dang it, let me do this. I need more of them. So let me scale it like this. 1, 2, 3, 4, 5, 6. I still don't like it. Still don't like it. 2. There we go. So, now that I've done, oh, it's a nightmare being me sometimes, having the OCD. And then f of 3 equals 6. So I know I've got those dots. Now, all I know now is this limit as I approach 2 from the left is at negative 3, and as I approach 2 from the right is at 5, equals 5. So, what that means is as I approach 2 from this direction, the y value is going to be somewhere, or it's going to go down here at negative 3. So this graph, I don't know if it's going to be, I'll just make it straight, but it'll look like that. I mean, I could make it curved or whatever, but it's just easier to make it straight. Then, so does everyone get that? So as I approach 2 from the left, the graph's y value is supposed to approach -3. But it's going to be a hole there because I already know f of 2 equals 4. And this is the graph of a function, so it has to behave like that. It can't have 2 solid dots for the same number. And then, as we approach 2, let's see, as we approach 2 from the right, it says that it approaches 5. So there would be a hole right there, a gap and a hole. So again, as we approach 2 from the right, the graph has to go towards, the y value has to go towards the number 5. And so that's how that graph would look. So it fits all of those conditions. It's kind of weird, but that's how it works. All right. My phone is buzzing. Let me take a pause and I will be right back. Sorry about that. That's the joy of making videos. It's never a good time. All right. This next one says to estimate the value of the following limit by creating a table of function values for h equals 0.01 and so on. So I'm going to come in here into my calculator. Let's clear out that old thing. I'm going to type this in. Now I'm going to have to use the x value or x variable. That's okay. And then raise to the... Now, if you have the old version of the calculator, you want to make sure that you put the graph or the equation's exponent in parentheses. So, if you have the old version, it would look like this. Oh my gosh. It would be 1 plus 3x and then caret and then 2 divided by x. And then we've already have our window, I'm sorry, not our window, our table setting to be on ask. So I just want to make sure that's in here so people know it's on ask. And then I'm going to go straight into my table. And I'm going to ask it for those values. So let me delete these out. And so it wanted 0.01. 0.001, 0.0001, and then it wanted, let's see, negative. So where's my calculator? So negative 0.01. Actually, let me do it backwards here. Negative, I'm going to do the closer one, 0.01, and then negative 0.001, and then negative 0.01. So, if you look at these values, so we're trying to find the limit as this function approaches 0. And so what I would think is that looking at, where's my highlighter? These two values here is where I would want to look at. Now, remember, I went kind of backwards here, right? I did negative 0.001, negative 0.01, and then negative 0.01. So that 0 would be kind of in the middle. And so I would probably want to estimate maybe about halfway here. So let's see. So that's 403. And this is about 403.8. So if I go halfway between there, this limit as h approaches 0 of 1 plus 3h, 2 divided by h, would be about 403.4. Now, I think it's going to have a little bit of leeway on that, but that's kind of what I would do. I would take those two values in the middle and average them. That would probably be your safest bet. This one had a little bit of an issue. It wasn't that close. Some of the other ones actually get really close, and then you get a little bit more exact. All right, so that's how you would do that, a problem like that. The next one, this says to use the zoom and trace features of the graphing utility to approximate the following limits. So I'm going to do number 40. I'm not going to do number 39. So again, come in here. Let's make that a little smaller. Y equals, let me change my mode back. I'm going to go to the old mode. If you're in the new mode, you could just hit the alpha y equals and put in that fraction all nice and pretty. But here, in the old mode, I'm going to have to do this. 18. Now, to me, the best way to get cube root is to do x to the 1/3 power. You could hit math 4. Math 4 is what you would hit to get a cube root. So I've got 2 parentheses to close there. Then divide by, and then x cubed minus 1. So we want to be a little careful. Now, use the zoom and trace feature. So we're wanting to know where this is going on when x equals 1. So I'm going to go ahead and change my window to be maybe 0 to 2. And then, I don't know about my y values. Let's make that go by 1s. So let's just make my y values go back to the normal -10 to 10. And see if we see anything. Oh, yeah. You see there's a hole there. Because you can't plug 1 into this. So those that can see. Now, I just got lucky on the y value. Oops, on the, oh my gosh, that didn't even paste what I wanted it to. I got lucky on, the window, is what I was trying to say. Because, I mean, just putting my y min and back to -10, that was lucky. If I'd been in standard viewing window, this is what I would have seen. And, I mean, I possibly could have done it like this, would have been fine. But because I want x to be around the number 1, I thought going from 0 to 2 would be helpful. So, typed in my equation, hit graph, adjusted my window so that I could see it. And now, I'm going to hit the trace button once it graphs. And so notice it says x equals 1, y equals nothing. But if I go a little bit to the left, it's 2.05. And then if I skip over it to the right, it's 1.89. So it looks like if I'm just to the right of it, oops, this is just not my day. And then just to the left of it, it looks like it's approaching 2. So if I come from the left side, oops, that's not what y'all needed to see. Good Lord. Oh. If I come from the left side, it's approaching 2, and I'm bounced a little bit more than 1. And it's also doing the same on the other side. So I feel confident now that I can say that, yes, this is approaching the number 2. All right, let's check and see how bad my time is. Oh, let's see. What's the next one? Number 45 is interesting. It says limits of an even function. If you have an even function, that means it has y-axis symmetry. And so you can use that fact. So y-axis symmetry just means that it, folds in half on the y-axis. And so here it says if f is an even function and for the number 2, the limit is 2 approaches from the left is 5 and from the right is 8. So here's 5. So as I approach from one direction, it's approaching 5. And as I approach from another direction, or from this direction, it's approaching 8. Now, I don't know necessarily which way it's approaching. I just know that as I get close to this direction, or close here, so that'd be like 1.9, then over here, if it's -2, then at -1.9, it would be approaching 5. So the limit as I approach -2 from the right of the function would approach 5. So, do you see how that direction switched? So we know this, and so when I flip it over, it goes in the other direction. And the same thing here. As I approach 2 from the right, it says that it goes to the number 8. So when I flip it over, fold it over the axis here, then I would be approaching from the left. And so it's kind of hard to see there. I think that first one's a +1. So basically what happens is they switch. And so the limit as x approaches -2 from the left of the function equals 8. That one equals 5. So that's not too bad. There's not too many more problems. This one is just talking about estimating that problem using graphs. And you can, just take and graph those 4 equations. And what you'll notice is that each time, because it's as you're approaching 0, for this graph, what happens is it looks like this. It's kind of straight line there at 1. And then if you graph the other one, it kind of humps up at 2. And then the next graph, so that's that graph. And then the next graph kind of humps up here at 3. And then this graph, guess what? Has a hump at 4. And so what's happening is that when you have the limit as x approaches 0 of sine of px over x, it's going to approach p. But you can see that by doing that graphing pattern, so that's kind of cool. And then on number 49, it says use a graphing utility to plot sine px over sine qx for at least 3 different pairs of non-zero constants p of q of your choice. Then use your work to make a conjecture. So if I let p be 8 and q be 4. So y equals, so I'm going to do sine of 8x divided by sine of 4x. Now, I'm going to zoom 6 this. See what happens here. So it's going to bounce around, bounce around, bounce around. I do think it doesn't give me a window range here, but what I'm going to do is I'm going to make my window range. I'm going to make my y's go from -2 pi to +2 pi because we're dealing with sine. And then I'll make this go by maybe pi fourths. And then maybe here -5 to 5. So, because I'm dealing with trig functions, I made my window here, -2 pi, 2 pi, and pi over 4. Now when I hit graph, as it approaches 0, it looks like it's hitting up here at 2. Okay. Let's see. So as I come from this direction, as I come from this direction, well, as I approach 0 from both directions, the graph looks to be approaching 2. All right, so now let me try another one. Let me try P equals 9 and Q equals 3. So if I come in here, all I have to do is now change this to 9 and change this to 3. Okay. I'm going to keep my window the same. And this time it's going to look like it hits up here at 3. Does it look like it's hitting at 3? Yeah. 1, 2, 3. Again, I could probably change my window even more. And I'm not going to do another one, but you could do another one to convince yourself that the limit here... Oh, it keeps doing it. I'll tell you what, guys. I'm so sorry. This has just been like a nightmare. Alright. There we go. So, as I'm approaching 0 from either direction, this graph appears to be approaching the number 3. And so notice on both of these, up here, P was 8 and Q was 4. And then if you divide those, you get 2. And then here, if I divide these, I get 3. So my conjecture would be up here that the limit here would be P over Q. And so that concludes 2.1.